Great. So, welcome to Data Club. My name is Roger. I am a fifth-year PhD student in Earth and Environmental Sciences. I study sea level change, and it happens that studying sea level change means that I spend a lot of time thinking about Python. This is Data Club, and today we are doing, I think, what we could call the third in a series of introductory, let's assume you don't know things about Python and show you a foundational way that we program in Python. So today, we're going to open up this Jupyter notebook and talk about Dask. And our objectives for today are to review pandas as a tool for data analysis and a little bit on the fundamentals of coding in Python, and then talk about what happens when you have so much data that you can't process with it on your laptop, for instance. That's where Dask comes in. And then we'll talk a little bit about ways to do statistics and visualization with these libraries, and then go from there. So where I started last week and where I want to spend a minute this week also is to say, if you don't know what Python is, let's chat about it. Python is a coding language. It's more than 20 years old. I'm going to fact check that with Moisir. I think that's right. It's 15 years old plus. But it's really taken a lot of the finance world by storm, a lot of industry and the scientific world, because it's easy to use. It's a much lower barrier to entry than a lower level, closer to the guts of your computer language, like C or C++. Why does it matter? Well, it's a tool. Like, if any of us owned a home, maybe one of us does, you would realize that you have to take care of your home, and you have to start acquiring tools to do that, like your roof breaks or something. And different tools have different use cases. So Python is a coding tool that is useful for a lot of situations and makes itself more useful in many situations by having subsidiary libraries that are written in Python, or often written in a lower level language, and then Python kind of wraps them in something that's nice to look at, so that then you can use a set of tools that the astrophysicists need, or statistics. So all these different knowledge area or domain specific tools get wrapped up in Python. What we are using today is an environment called Google Colab. Google Colab is supported by Google, and Google's computers are running in the back end. So it's a cloud environment where you can run code, and you're provided in this environment with a small amount of RAM, random access memory, and a larger amount of storage space. So you can treat Google Colab like a small computer and download files to it that will persist for a short amount of time, but long enough for you to do coding in it. And the reason that we've wound up using Google Colab is that when you're teaching an intro Python class, often the first day is just spent trying to install Python on different laptops. Some noble user has a Linux laptop, and somebody else has has Windows, and then and there are different challenges with different laptops. We avoid those challenges by working in the cloud. I'd be happy to help anyone after if you want to put Python on your laptop, or we can set up an appointment, because that's also very useful. You're not always connected to the internet. But for now, Google Colab also has a bunch of nice features built in. There are a bunch of ways that Google Colab, and we'll look at these more as we go through, helps you out, sort of auto-completes, and gives you easy access to help features or the documentation for Python. And so let's jump in. So the first thing that we do typically in a coding session is install the libraries that we need. And libraries, in this case, refers to modules of code that are wrapped up and downloadable from the internet that then do specific things. So the way you operate Jupyter Notebooks and Google Colab is there are a series of cells, and each cell can run. So press the run button on the left-hand side of the cell, and it will tell you that this notebook is not authored by Google, but let's run it anyway. I'm not Google. And what's going to happen is that in this cell, you've typed exclamation point. Well, you see exclamation point Python. That means use the Python language. And then pip install. So use this programming, this library manager called pip. Install these two libraries, Fast Parquet and Dask. Fast Parquet is a file format, very much like a comma-separated value, CSV, which is like a basic version of an Excel file. So a Parquet is basically just an optimized CSV that has kind of replaced CSV for big data because it's more efficient. And so you see a bunch of requirements already satisfied. We install the things. The next thing we do is import libraries. And Google Colab has in its background installed a bunch of libraries, which is why we didn't have to install most of these. And that means that it's got them sitting in the shed, and we just have to take the tools out of the shed and say, we want to use these. And what you do when you metaphorically take the tool out of the shed to use it is you import it. And typically, because coders are lazy, we don't want to write pandas every time we want to invoke something that's related to pandas. So we say import pandas as PD. So PD from now on is going to be our shorthand for pandas. We're going to run this, and it runs quite fast. In addition to pandas, we're importing matplotlib, which is the workhorse plotting library of Python. We're importing a stat library, a few other subsidiary libraries that will help us getting information from the web. OS is like an operating system library. NumPy is the basic library for computation. If you want to do a cosine or a sine or correlation, like any sort of computation, that's where you go. And then Dask, which is this library that we're going to spend a lot of time thinking about. Dask is the one of the hot new libraries that's grown up to deal with big data. And the data that we're going to use is the same data that we used last week. The New York Taxi and Limousine Commission trip record data website has, I'm going to click on it so we can look at it quickly. It has a bunch of years of New York taxi ride data. So everything from pickup times to drop-off times to fares, This may or may not actually load, which is fine. And what we're going to do is we're going to download some amount of it. The way we do this is we are going to send a message to the taxicab website and say, hey, we want some data. And the first thing that we need to do is to make a place to store the data. So these lines of code, I'm going to take them out and mouse over the center here and press code and paste them in so that we can look at just what they do. So path, we don't need that F. Path equals blank is just saying this is within this directory, we're going to make a folder called taxi underscore data underscore parquet. And then we're saying if there is not a directory called taxi data parquet, then make that directory. So run that cell, and you should see taxi underscore data underscore parquet pop up in your on the left-hand side of your screen. If you mouse over the files folder and click that, you should see taxi data parquet. Oh, I love it when people smile. It works. Such a satisfying feeling. OK, great. So now we have taxi data parquet over there. And now we're going to say, I'm going to learn how to use a computer. And now we're going to say, OK, so we're going to download 2 years worth of data. We need months and years. So let's make, I'm going to put this in here so that we can see it, months. We're going to say for numbers, integers from 1 to 12, take each integer from 1 to 12, and if it's 1 character long, add a 0 in front of it. If it's 2 characters long, don't add any zeros. But and turn them from integers to strings. So what we wind up with is 0, 1 to 0, 9, and then 10, 11, 12. There's a lot going on in this line. It's not crucial what we're going to do here. I will spend a second to look at it. If we remove str and run it again, we'll find that you can't do strfill on an integer. So let's take zfill2 away, and you'll see that it just is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this zfill is adding in a 0 in front of it. And the reason we need that is that when we ping the taxicab website, the way the taxicab website has stored the months is 0, 1 to 0, 9, and then 10, 11, 12. OK. And then we're also going to make a variable called years that has 2019 and 2020 in it. Quotations in Python turn something into a string. A string is a set of characters. A string is a variable type, just like an integer, just like a float, which is a decimal, a number with a decimal place. So we have a list here. List in Python is delineated with brackets. So we have a list that has years and a list that has months. And then we're going to loop through years and loop through lists. So we're going to say for each item in years, for each year in years, do this. And then within that, for each year, for each month within that year, we're going to make a URL that has the month and year and make a string that is the name of the file, which is a Parquet file. We're going to use this requests library to ping the taxicab website and ask the taxicab website for this file. The taxicab website will be nice and give us the file, and then we are going to open the file as this file name that we're going to give it, along with the path, which is the path to taxi Dask. Okay. So I'm going to run this, and then with it open, we're going to write that file. So basically, we're taking data from the web and writing it into this Google Colab environment. And then the last thing in this cell, once we do that, then we're going to open up one of these files just to look at it. And the way we're going to open it is with pandas. Pandas has a method called readParquet. So the library, pandas, has a tool called readParquet, and that allows you to read a file. It's like what's under the hood if you double-click on an Excel file. You're reading it, you're opening it. It's the same thing with this. OK, so let's do this. And because I asked it to print every year and print every month, you'll see that it's slowly reading months in for 2019. And they're taking a little bit of time because there were a lot of taxi rides in 2019. And then 2020 hits, and then, oh my gosh, there's no taxi rides because it's COVID. And so it goes really fast. And at the end of this cell, we asked it to read in the file. So now we can see this file. I'm going to pause a second and ask if there are questions. No? OK. I say this at the beginning of every one of these I do, but the purpose of this is to learn things, for you to learn things. The purpose is not for me to yammer. So whatever needs to happen in this next hour and change for you to learn what you want to learn is what should happen. Cool. So we now have, if we open that folder back up and click on Taxi Parquet, we have yellow trip data from 2019 down to 2020. So we have 24 months of taxi cab trip data. And we've opened up one of those files. And the way this looks very much like an Excel spreadsheet because that's what we're familiar with, so they designed it that way. This file has a bunch of different headers: vendor ID, pickup date, drop-off, passenger count, trip distance, et cetera, and fare type, MTA tax. So a lot of data. There's more than we'll actually need or use, but it's there. And the file format is Apache Parquet file. So to look at how much data we have, we're going to use one of the tools that is built into Google Colab. So we have been working in Python, but if you've ever used the command line of your laptop, the command line, typically the commands that you type into your command line are in a language called shell scripting, often in an interpreter called bash. And bash, I think, stands for born again shell. So like the shell is sort of your, it's like, there was a terrible movie in the geoscience world called The Core. And in The Core, these humans build a ship and drill to the center of the Earth. And in the center of the Earth, they find like amethysts. It's totally not realistic. There's like, you can't do that, and there's no empty space in the center of the Earth. It's iron. But this concept of like a container in which you do things, I think is maybe helpful to think about a terminal as a portal into controlling your computer. So bash scripting is a way of feeding commands into Google Colab, the computer. And what the commands that we're going to feed it are first cd, change directory, into this directory that we've created, taxi data parquet. And then we're going to use a command called du-sh. Du-sh stands for disk usage. That's the du part. And then the flag is total size is the S, and H is human readable. So make it in a way that we can understand. So we'll run this, and it tells us 1.6 gigabytes. So what we've learned is that in taxi data parquet, we have 1.6 gigabytes of data. Cool. And we might also want to know how many files do we have. 24 you can count, but if you had 300, you couldn't count. You would want somebody to count for you. And to do that, we're going to do the same thing, but we're going to use a find command, and then a second command, word count. Find goes through the current directory that you're in and all subdirectories and finds whatever. In this case, we're saying find everything. And then we say, with the things that you found, that's what this pipe means, like take the outcome of this command and then perform on that outcome word count by line. So just count the number of lines. And when we run that, we see 25, which is one more than the number of files we have. I think if we do f-find-file, live coding never works. That's irrelevant.
Just do ls instead of find dot. ls-l.
You could do ls-l, which would also be 25. It's fine. In any case, we've got the information that we need. And you have some cool bash scripts in your back pocket now. du-sh is very useful for figuring out how big files are, or like containers of files are on your laptop. So we've got a bunch of files. We don't want to load them all individually. That would be wretched. Instead, we want a way to load them all at once and do things with them all at the same time. And so what we're going to do is use this command called glob. And to figure out what glob is, I'm going to mouse over it. And that opens up a description of what it is. So glob is a function. I'm going to open this in tab. Open in tab. Is that going to work? In any case, it's a function that takes in a path name, so a path to a directory, and lists all the paths within that directory that match the pattern that you're asking for. Where this gets powerful is that you can feed in what are called wildcards. So feed in a star. And so the way to read this is to say, glob, look in taxicab._data_parquet and return all of the files that start with yellow trip data and end with parquet and have something between them. The star is like whatever. It's like you've got yellow taxicab and parquet and like whatever else. That's what you're telling the computer. And then I've wrapped that in sorted, which is a Python native command that sorts a list. And then we're just going to print the beginning and the end. Let's actually be simpler, and for now just say let's print the file names. So we'll run this, and you'll see a list of files because they went to taxi data parquet and got all the files that match this, which is all the files. If you take away print, you see that because file names is the last line of this cell, it automatically prints for you. And so because we've sorted it, the files are in order. If we removed sorted, glob does not necessarily choose files in order. So you see it's gone through and it's chosen them all out of order. Sorting is not that important, but I wanted to give you that tool. Nice. So now we've got files, file names. And let's open one of them to make sure that we are still doing the same thing. We open it. And look at how long it is. Almost 8 million taxi rides in this file. Which one was this? This one, that file that we opened was January of 2019. So in the greater New York area, people rode 5 million taxi cab rides. And if we wanted to look at 2 or 3 years of data, that's more than 100 million taxi rides if every month had the same number. As you'll see, once COVID hits, there are many fewer taxi rides. But still, it's a lot of data, and it's too many. I think even if you tried to load 1 month of data into Excel, 9 million data rows would start to crash your laptop. It's fine for pandas, but much more than this would not be good. And I want to orient you towards this system RAM because the limiting factor on our work today is going to be us running out of RAM. So we may have to restart this notebook a time or two. Typically, if you're working in a cloud environment, you have more than 12.7 gigabytes of RAM. That is what it is. It's a limitation that we're working with. But one of the reasons to use Dask is to economize on things like RAM. OK. So I played with this quite a bit yesterday and played with the full data set. And I'm going to show you the full data set just so you see how big it is. And we're not going to play with the full data set because then we'll run out of RAM quite quickly. We're going to work with a more limited data set. But run this cell. There are a bunch of lines of code here. All of this is using Dask data frames to read the Parquet files that we downloaded with the first argument being, let's mouse over this. The first argument is the path. And then it has a bunch of different optional arguments. This def read Parquet, parentheses, humana, 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 end parentheses, is how Python describes a function. So a function could be as simple as 1 plus 1. Take in x define a new variable that is x plus 1, return the new variable. In the interest of making good on the promise of this being starting from 0, let's do that. Here's a function. Define add 1x. Let's say y equals x plus 1. Return y. So this is not a trick question. What do we think y is going to be? 3, yeah. And it's going to be 3 because we say we've created this function, add 1. We're taking in whatever, we're adding 1 to it, and then we're returning that new thing. This is the way that Python functions read. It starts with define, def, and then you create the name of the function, and then you have this colon, and that says whatever comes next is the function. Python cares about indentation, so everything that is indented after it is part of the function until a return statement. And actually, even a return statement doesn't necessarily end the function. You could say if y is greater than 2, return y, else return too small. So then if we had add 1, y is not greater than 2. And look, my kernel I just ran out of memory. Incredible. Okay, so I'm going to re-import these. Hopefully you have not run out of memory. And we are going to rerun these cells. Oh, I don't need to do that. You can stop a cell by pressing stop. We don't need to rerun this cell because we still have the data downloaded, so that's fine. And we make the file names. We don't need to run that. Okay. So add 1 of 1 is too small, but add 2 is good. So this is a fundamental part of coding, if-else statements. Good. So that's what read Parquet is like. It's just a function like add 1, and what it does is it reads Parquet files. We're giving it some keywords that say use this particular library to read the Parquet files, and we're saying these 2 columns, hey pandas, read these 2 columns as dates. One of the reasons that people made pandas is that all the finance types and other people, scientists, anyone who's working with time series data, you have to deal with the fact that there are leap years, the number of seconds. Like we add seconds every, I don't know how many months. So time is actually a kind of a thorny problem, and pandas has built an apparatus in the date time module to deal with that in a often quite easy or at least functional way. So we're telling pandas, hey, read this as a date. Okay. And then
do you have to?
You do not have to.
No, sorry, that's opaque. One of the things that I learned from the last workshop was that Parquet files actually encode date time into the data type. So like when I took that taxi data and imported it in JavaScript, date time was already taken care of.
I think that is true, and I think it's also true that the people who made these data sets already have made them date time objects.
Yeah. So I think
we may not need this.
I think you definitely needed this 2 weeks ago when you were copying from CSV.
CSVs, indeed.
Because in CSV, everything is just text or number, strings basically.
Mm-hmm.
But presumably, I'm not 100%, but presumably I think that you can skip it here.
Yep, I think that's true.
Nice.
And we can test that out by running this without, and sure enough, okay, so somebody describe to me what we're seeing here. And let me be a little bit more specific. Can you compare this to that? What is different about this?
Data type?
Yeah, it's telling about the data types of that columns.
I love that. It's telling about data types. What else do you see? Obvious things are fine.
It didn't read anything in?
Great. So you're observing that there's a lot of dots, but you're not actually seeing data. What does it say here?
Partitions.
N partitions equals 24. Okay. And how about here? 24 tasks. You all are doing great. It's very small text, I recognize. Okay, so this is important information. What Dask does is it doesn't read every line of every file. Instead, you give it a list of files, and it reads the first file and then says, I'm going to assume that all the files have the same type as this first file. All the columns have the same type. So int 64 is an integer that is 8 bytes, I think. Float 64. And then it uses that to map onto all the other files that it loads, unless told otherwise. You can tell it, oh no, actually, I have more information about these files, and I'm going to tell you more precisely to load in with, tell exactly what data types there are, for instance.
Where did Dask come from? You're just running read parquet.
So DD is Dask data frame. That's the little, so before I was using PD, pandas, but scrolling up to the top, I imported Dask data frame as DD.
Sneaky.
It was very sneaky. I didn't tell you about it. I should have told you more explicitly. So all of a sudden we've jumped into Dask world.
Can pandas do this? Assuming, okay.
Pandas reads in, as you saw, we used pandas to read in one of these files, and it read in every single file, every single line.
Okay.
And so Dask doesn't actually know how long the file is, which means that it's possible, which means that it takes some work to tell how long it is. So we're going to run len, which is the command for how long is something. And what we get is, it's 109 million files, 109 million taxi rides. Because we have almost now used all of our RAM again, I'm going to go back and run this with fewer files, because right now we're using all the files. So we're going to do just the file January, February, March of 2020, and then the 3 months after. So we're just looking at the transition pre-COVID to COVID, because that is still quite a lot of data. Yes?
What is 12 to minus 9 means?
Wonderful question. Good. So file names, I'm going to answer this, but does anyone have any guesses about what 12 to minus 9 means?
I know it's indexing, but how does indexing 12 to minus 9 works? I didn't.
It's totally hard coding this. So remember, hard coding means using numbers instead of, which is a little bit brittle, and typically you don't want to do this. We have 24 files. They're organized. It's a list organized from January to December of 2019, and then from January to December of 2020. So we are, by starting from 12, the colon means go to the end. Now, we only have, this is only 2020, and then we're going to say only take, don't take all the way to the end, take 9 from the end. Stop when you are 9 away from the end. So, stop when you're 9 away from the end. That's there. Or we could say stop when you're 6 away from the end.
Can you do 12 comma 3?
Comma would be saying that it's two-dimensional.
Okay.
And so this will break because as a list, it takes integers but not tuples. But good question. Okay.
Because I thought there might be like pick an index and then n members after that index.
Also, rather than saying minus 9, can't we just say 12 to 3?
So let's try that. If you go from 12 to 3, then you're saying start at the 12th member and only go to the third one, but you're starting after where you want to end. So there's nothing.
That was kind of what I was asking, except I was saying add 3 to so. But you could do 12 colon 15.
You could do 12 colon 15, certainly. Mm-hmm. Yep.
Well, probably 16. Oh no, that is
Or whatever.
inclusive. Okay.
Or 18. Mm-hmm. Yeah.
What does the 12 colon mean again?
Good. So the 12 colon means start at 12 and go to the end. The colon is like a keep going until you reach, in this case, the end of the file. They're the end of the list. Yep.
But if you start with the colon, it means start at the beginning.
Start at the beginning and go to the 12th one. I know. It's like there's a reason people get in like coding manic things and just spend hours at it.
How to use Excel. This is way too overwhelming.
Yeah, this is like drinking from the fire hydrant. Okay, so we're going to load a subset of these files. And because we loaded 6 files, the Dask data frame is partitioned into 6 pieces because it loaded 6 of them. And it took 6 tasks. So Dask is built for computers that have, like all of our laptops and distributed clusters, where you have multiple workers or multiple cores or basically multiple computers doing tasks for you. If your laptop has 4 cores, you have 4 different, basically, processors that work together to do tasks for you. And what Dask does is it says, okay, you want to do this task? Well, you tell me, you say do it, but I'm not actually going to do it. I'm just going to draw out a diagram for how I would do it. So I make this little graph, and then when you tell me, no, really do it, go, compute. Then it sends the tasks to its to the workers, to your 4 cores, to the 100 workers that you have on a cluster, and efficiently partitions their effort so that even if you're out of memory, if it's more than, you're working with more data than you have memory for, you won't run out of memory. So it's a way of kind of, it's a force multiplier for code. Yes?
Question. So I've been trying to do this locally as well, and for me, when I try to look at the, well, let's just say the DF cell, it says Dask name read parquet, but for me it's saying one graph layer instead of the six tasks.
It's saying one graph error?
Layer
Oh,
instead of the 6 tasks. Why?
interesting.
Why would that be?
Is this the engine maybe, that fast parquet engine also that you loaded in? Like that may,
I'm not, it
Did you
kind of
include that
depends
line?
on,
okay.
One graph layer is not something that I've come across, but it could be how your laptop is built versus what is on the back end of this. Let's keep going and see how it performs locally.
Does it depend on like the GPU, or is
If
there
you maybe if you have a
something
GPU, maybe that in your laptop. I think this is all CPUs,
that's- Oh,
so that could be it. Okay, so now we have a data frame with 15 million entries. And so we've stitched together 6 of these months, and there are lots of things that we can do with it. One of the things that we can do is to say, give me the first 5 rows. Take the head of the file. And it's going to run the head and give us exactly what we had up here. 190101 4640. Let's just check.
So you're
Oh, I'm sorry. It's because we haven't actually rerun this cell. This should be oh, it would be 12.
Yeah, 12.
Yep, thank you. 0101 2815. 0101 2815. Cool. Okay, so it's doing the same thing. We're going to do a little bit of data processing, and I'm going to bring back a few cells from last week just to review what these different data types are. We've done that a little bit already, but just as a refresher, lists have lists of are data structures that can contain essentially any variable, integers, strings, and we can index with them. We just looked at that. Another data structure is called a dictionary. And a dictionary, just like an actual book dictionary, has entries and it has values. So you have abracadabra is a wizarding command, and presbo is an old president of Colombia, etc. And just like in a dictionary, you can look up, if you know that you're looking for Rory, then Rory, what the dictionary will tell you that Rory is the lion. But if you try to search, I'm really struggling with this, Dick Tex, the lion, this will break because the lion is not one of the entries in the dictionary. So you can only search the key and get the value. Yes, exactly. Cool. So in our data frame, which we've abbreviated with DF, the columns going across the top we saw before are things like vendor ID, payment type, etc. Some of these we're going to use, but they're a little bit long. So what we're going to do is we're going to make a dictionary and replace the column names with easier column names. And then we will look at the head of it again, and amazing, we have easier column names. What we did here was we said rename the data frame with the columns as mapped by this dictionary. So where there was tpep pickup date time, replace that with pickup. Replace trip distance with distance. Just just swap them out. Cool. And just to confirm that whereas before last week, what we were working with was pandas series, this week we're working with Dask data frame series. A series is just a column of an Excel spreadsheet. So whereas a data frame is like the entire Excel, we can also slice out a single column, and that's in this world that we're working in called a series. The columns each have a data type associated. Dask knows that. Remember, we saw that each column, it knows what the data types are, even though it doesn't know what's in the columns. Okay. So last week we ran this command, describe all, on the pandas data frame that we were looking at, and we got a bunch of summary texts. So we just ran this cell, and it broke. So could someone read or look at this message and take a guess about what happened?
Well, so can you scroll up to the data types again, please, for me?
Yeah.
So that last thing, the airport fee, is saved as capital I int 32, which is not a data type that I'm super familiar with, and it sounds really old-fashioned because it's only 32-bit as opposed to 64-bit. So is it the case that Dask is just like, this number's too old, man?
Yes. Mm-hmm. So it ran into
Numbers
this.
can be old.
It ran into this airport fee and said, "Oh, what is that? Int 32? I don't get it." So
As a 32-bit integer, that means int 32 is between 0 and something like 65,000 something. Or
Yeah.
I think.
yeah. So it hated that. So one thing we can do is filter out to only include floats. For instance, we can run that, and then, oh wow, it worked. Describe is not very helpful if it's in Dask form because there's no actual information that's showing. So really, we would want to do .compute. And so here is the first time that we're telling Dask, okay, go, do it. I told you to do describe. Now actually do it. And based on our RAM, I think we're going to crash, but let's give it a try. Maybe we won't. That would be nice. And so what's going on behind the scenes is that Dask is, oh, we crashed. Boom. All right, let's go back. I feel like this is like, you're 5 years old or 2 years old and trying to run, and you're just like walk, run, run. Yours worked? Woohoo!
Yeah, it works on my computer too.
That's great. That's what we love to see. So let's get back on our wagon.
12 gigs is not nothing either.
I know. Okay, let's go down. We have to run this cell to replace the columns. But to speed it up, I'm going to disable that. And we go down to here. That broke. I'm going to comment this out since we're done with it. And let's run this, and we should be fine now.
The problem is the little RAM meter is blocked out on the recording by the bug.
Oh yeah.
So the viewers on the internet can't see that line just go
Yeah, cool. But while this is running, let's talk about, aha! Amazing. Okay. So we get all these cool statistics about the number of passengers, the total number of passengers in this 6 months period, the mean number of passengers. So taxis on average in this time had 1.49 people in them.
Excuse me, that's 1.49 times 10 to the 0.
Yes. Indeed. It's good to be precise in these things.
I'm just amused that it gives everything in scientific
Everything in scientific notation. I really would have loved to see like the one taxi that had 9 people in it. That's just, I guess there's like, it could be some sort of like van or something, I don't know. But okay, so lots of useful information here. Let's talk a little bit about what Dask is doing and why it's different from pandas. So Dask, whether you're using data frames like we're using, or Dask is a large ecosystem, it also has different features for arrays and things like that. When you tell it to do something, it builds this task graph. And then once you say go, it sends the task graph to scheduler that schedules on the different threads or on the different nodes that you're working with. And one way you can look at this is through the visualize method. So if we do this command, df.iloc is selecting a column. Is that right?
It's index location, so
it's a row. It's a row.
It depends on the shape of whatever you send.
It's a row, right?
It depends on.
Yes,
Yeah.
indeed. I think Dask actually doesn't accept. I think it's columns. I think Dask breaks with. Yeah, it only supports selecting columns because it doesn't know how many rows there are.
But if you did 0, 0, would it give you just the one cell?
No, I don't think it cannot do rows.
Okay.
But basically what we've done is we've said take the first column, just as a simple thing. If we do visualize, then because we've got 6 months, we've got 6 different files that it has 6 different tasks, which start off with read parquet, and then there's this get item, and then rename it, and then get another item, and then it's done. So that's behind the scenes. When we said .iloc, it built this graph and said, okay, at the point when you actually tell me to do this, I'm going to do this. It hasn't done it yet, but that's what it will do. So graphs can get more complicated. Here's taking the passengers, df.passengers, we selected the passengers column. And then we said, let's take the mean number of passengers. And then we created this variable, mean passengers. and now we said visualize it. If we look at mean passengers, you'll see that it's a scalar, but it's not telling us what the mean is because it hasn't done the computation yet. It's just planned out how it's going to do it. And looking at what the plan is, it starts, just like before, with this read parquet, and then it splits it up into chunks and does the sum on these different chunks, and then sums up the sums, and then counts them and takes the mean of that, and you get an answer. I think it's just like, I could look at these graphs all day. It's so cool to watch the computer split things up. But okay, so that's what it's going to do. Another helpful tool, because, okay, let me step back a second. You could imagine if you have a lot of computations to do on a data frame, adding up more and more tasks. The graph gets bigger and bigger and bigger. And at a certain point, the scheduler just says, I'm done, I'm out of here, I can't stand this, and breaks. If there's like 100,000 tasks that you're asking it to do, there's a limit on the number of tasks that it can deal with. So often what best practices for Dask are is to, at a certain point, partway through whatever set of tasks, whatever set of computations you're asking it to do, type persist. So what persist does, and it says, whatever tasks you have right now, start working on them. Don't compute, don't get the final answer, but start working on the tasks. So persist sends off, kind of like snips off the graph wherever you are, and sends off those tasks to the scheduler. So let's run this, meanpassengers.persist, and this is going to use some RAM because we're putting it in memory. We are using memory to do these computations. But then when we say visualize, it's snipped off everything except the 0. It's run everything except the 0. But if we just look at in mem, mean passengers in mem, it still won't be computed. It still will be a Dask. It should look, I didn't save it, but it should look there. It's still a Dask scalar. It's just, it doesn't have any graph associated with it. Does that make sense?
I have a quick question. If you have a ready answer, I guess it's okay. Otherwise, I'll look it up. But when I tried to do the visualize locally, it said I needed a couple other libraries, GraphViz, and Cytoscape, I think. I did install them, but then it says fail to execute Windows path. Sure, GraphViz executables are on your system.
So this is the challenge with piecemeal installing libraries.
Okay.
Typically, the best practices for local use of Python is to have an environment.yml file. And what that does is it lists all the libraries that you want to use. And typically with Conda, the package manager, installs all of them in a way that respect their individual dependencies and so that they play nice with each other. And it also means that you have this like padded cell, like a little sandbox that you can step into and work on whatever, work with whatever libraries you want. And then you can step back out of it. So you haven't polluted your computer with a bunch of libraries that you then need to delete. You have this like sanitized environment. So it makes sense that you're getting that sort of error if you're piecemeal installing libraries.
I had to quit a project because GraphViz wouldn't install. So,
Yeah. Cheers.
yeah, it has to be possible somehow, but especially on Windows, I bet it's going to be something tricky.
Yeah. But that shouldn't actually hinder you in Dask. It's just like you won't be able to visualize stuff, which is, it's not actually that big a loss.
And in that case, is it just better to use Conda?
If you're not using, do you have like Anaconda or something installed? Yeah, then I'm not in the habit of doing this, but the appropriate thing to do is to have a different, what are they called?
Environment.
Conda environment or whatever, and then
Yep.
and GraphViz may not be part of the base Conda environment.
Yep. Yep.
But I imagine if you want to get the visualizations to work, I imagine Stack Overflow is in your future, because that may be tricky to solve.
Yep. The way Dask is designed, there are some things that are very fast and there are some things that are very slow. I've listed a bunch of the fast ones operations here. The things that are slow are things that require Dask to reshuffle its index, because then it has to, because it knows what the index of the data frame is, but it doesn't know the order of anything else. So if you're asking it to reshuffle based on some other column, like sort by fair type or something, then it requires more computation. Whereas if you're just saying add the start time to the end time, or like subtract start time from end time to get fair time, it's just going to do that out of memory, which is what we're going to do right now. So we're going to say ride time equals drop off minus pickup. It was instantaneous, essentially, and we get this ride time. And then we can do all of this. We can say, let's look at ride times and persist and then compute, and what we'll get is a list of how long each taxi ride took. So 4 minutes, 7 minutes, 6 minutes, etc. There are other tasks that are somewhat fast. I've listed them here. And we're going to look at one of those tasks, but first we're going to give ourselves a few more columns that are the pickup day, the pickup year, the pickup month, which is just taking pickup, which is a date time column, and splitting it and using some of the date time properties to add those in. And with that, we can start to use some of the cool features of pandas, which is group by. So you can say group by pickup day. You have this data frame with 31 different pickup days, first of the month through the 31st of the month. Split up your data frame into groups based on which day of the month it is. Select the pickup column and count the number of pickups per day, and then start working on it. Go persist. In order to plot, you have to call it into memory. So we call compute, and then we say plot and make a plot whose kind is a bar chart. And this will tell us how many pickups per day of the month were there in this 6-month period. And kind of makes sense. On the 30th and the 31st of the month, there are fewer because February doesn't have 30th and 31st, or 29th. Did it in 2020? Oh.
Did we have an election in 2020?
Yeah.
So there's a leap day.
Interesting. So
Except for 2000.
it's a mystery why there are fewer pickups on those days.
No. February there was a 29.
Oh, but not the other months.
You have January, February, March, April, May, and June. So
Indeed.
January has 31 days. March has 31 days. April does not. May does.
Yep.
June does not. Okay? So, but February only has 29. So that's why the fall off is for 30 and 31.
Indeed.
If it were for 2019, you would expect 29 also to be lower.
This is great. This is the things that I need to know before I defend my dissertation.
You know, you have to know about leap years.
You got to know about these things. All right, I want to show you a few more things. We're near the end. So we talked a lot last week about data wrangling, about cleaning data, and how Pandas makes that easy. So here's kind of a nuanced but interesting way of data cleaning, which is to say we would expect that fares and distance should correlate, right? Like the longer you drive, the more your taxi ride should cost. So we're going to create a data frame with only distance and fare, and take the correlation between the two and compute it. And we would expect that these numbers would be high. We would have something more than 0.001 correlation. That's crazy. That's saying there's no correlation between the two. Which you could say, well, the world is broken. Or you could say, my data set probably has a bunch of numbers in it that I don't want. Because for various reasons, there are data in it that are incorrect. I went to the trouble of doing some of this cleaning, doing things like saying, we know we actually only wanted 2019 and 2020, in this case only 2020, so let's choose only the parts of the data frame where the pickup year is greater than, we can say, 2019. And let's choose only rows in the data frame where the fare is between $2.50 and $500, and where the distance is between a block and 500 miles, and where there's more than 0 passengers. Yes?
These are all Dask thingies.
This is all pandas. This is just slicing.
Okay, but at some point you're going to have to run compute to actually get this stuff, right?
Correct. So now we're going to say we have this new data frame. Let's do the same thing. Let's take distance and fare and the correlation and compute. And we've chopped down the data frame.
While it's thinking, because the panda stuff only took a second. So when you played that cell. So that strikes me as weird.
Sorry, this is all in Dask, but it's commands that are shared with pandas. So we are slicing the Dask data frame.
But it doesn't actually get sliced. The computation doesn't happen.
Correct.
Until you run the next cell.
Correct.
So that's why it was 0 seconds there.
That's why it was 0 seconds. And we should see, if we look at this, that there are more tasks, because it added tasks to the, what do I have to do today? But how cool is this? Now the correlation is 0.94. So like something's working there. How's my RAM doing? Yeah, we're about to crash, so I won't show you the correlation between passengers and distance, even after cleaning, is still very low. Turns out it's not the case that you pile more people in the car to go a long distance. Some people take long taxi rides alone. Good. I put a graphic here explaining why shuffling is slow. I think we can skip over that, except to say that shuffling becomes very expensive with lots of data, and so you get big task graphs. And the last few things to show you are to say, now that you've cleaned the data, now that you have done all these things, you can start to ask questions like, how did the average number of passengers change during the pandemic, pre and post, for instance? Or like, let's look at the tipping. Let's look at the mean tipping before the in COVID and before COVID. And we may run out of RAM, but I was curious, did people tip more when they were riding during the pandemic, or were they like tight with their money, for instance? And our session crashed. So maybe I'll leave that to you as a mystery. But I will tell you that the number of rides before COVID is in the millions, and the number of rides after COVID is something like 188. So in the 3 months after, like March, April, May, or April, May, June, I think, 188 people took taxi rides in New York City. It's like crazy. Anyway, so I left a bunch of more questions here, but that's where we've arrived. Any questions about the torrent of information that you just experienced?
Curious about the change of tips. So what's the
Fair enough. We can do that.
Okay.
Yep, we can run
Do you know
this.
the answer?
I do know the answer because I ran this last night. Okay, so we need to run that, and we need to get the file names. We don't need that. We do need to load the data frame in. We do need to run the columns, and I think that's it, except we also need those, and we need to clean the data set, and then we should be good to go with this. Tips, tips, tips. And if luck smiles on us, we'll get the answer to our question. Yeah. So this notebook, while this is running, I'll say that this notebook will stay on GitHub. You can continue to run it through Google Colab. Use whatever the code you like. Okay, so COVID average tip is $1.69.
And it's during the pandemic.
That is after, or that is April and after. So April, May, June. Which is less than the pre-COVID tip. So people are getting stingy. At least that's what these two numbers would suggest. We looked at this. I look at the standard deviation to say, well, maybe there's just a bigger spread.
And
And-
they're taking shorter trips.
Maybe they're taking
So the
shorter
percentages-
trips.
The percentage may still be the same of the fare.
2.5 plus or minus 2.5 for the 1.69. Pre-COVID.
That means that, like, 40% of rides, the taxi driver gave the passenger a tip.
It's probably not normal. I would imagine. Okay, so exactly the same standard deviation, essentially. We're pushing it, but we're not gonna. I think we're gonna make it. But
Sorry, it's just a thing about the COVID thing. At least I remember with public transit, essential workers, especially nurses, they got free public transit. I don't remember the taxi thing. If there was like free rides or something available, like something like that.
yeah, I believe that. I mean, because people were also just getting crazy unemployment. Okay, so we've got 6 million rides in the 3 months prior to COVID and 900,000 rides after, in 3 months after. So not quite 188. I was wrong. I think that's just the 1 month after was 188. But still, huge drop off. And with that, I think I'm going to take this mic off.
All right, let me stop recording.